Amazing. Thank you so much. Hello, everyone, and welcome back to another episode of Indexer Office Hours. Today is the 18th of April, and this is IOH 103. I'm loving the profile picture there, Juan. You're looking very snazzy. If anyone is new to Indexer Office Hours, this is the town square where ecosystem participants come together and discuss the most important and relevant topics for indexers. Just to let everyone know, this is a call that is recorded and will be published onto public channels like YouTube. So if you're concerned about privacy, please bear that in mind. With that being said, this is a conversation and we love participation. So at certain parts of today's conversation, if you'd like to get involved, please do unmute your mic and let us, or use the chat box. And if you're having any issues with your mic, let us know and we can try to get you sorted out. Let's get into today's exciting agenda. So as always, we start off with a shout out for the GRT IQ podcast. We have GRT 112 with 𝗨𝗀𝗬𝗂𝗧𝗂𝗋 𝗂𝗂𝗧. And for any of you who don't know, 𝗨𝗀𝗬𝗂𝗧𝗂𝗋 is a graph advocate and a member of the Graph Advocates DAO. There's a few members of both of those initiatives in today's call. And this episode was very interesting because he recently launched Graph Central, which is an all-in-one resource for the community. And this conversation was very interesting. A little bit about his story, how he came to learn about the graph and then become more involved in the ecosystem. And so if you're interested in hearing more about 𝗨𝗀𝗬𝗂𝗧𝗂𝗋's story, I'd recommend checking out this particular episode. I'm going to link it in the chat just so everyone has access. Let me just go ahead and do that. There we go, enjoy. And with that, I'm going to hand over to Anna, who's going to take us into our regularly scheduled repo watch.
Thank you, Abel, and hello, everyone. All right, so let's start by like how we always start with execution layer clients. Here we have had a new release for Avalanche. So this is release 1.10. And in this release, so this upgrade contains linearizes the X chain, which introduces delegation batching to the P chain and increases the maximum block size on the C chain. The changes in this upgrade will go into effect 11 a.m. Eastern Time, April 25th on mainnet. And what that means for users is that all mainnet nodes should be upgraded before 11 a.m. 25th of April. And if you want to learn more about X-chain linearization, I have added a link. Some other changes included in this. The flags usage is replaced with P flags. There is new support for tracking delegates' rewards to validate their metadata. The addition of Gossip Avalanche Frontier after the linearization, and fixing concurrency bug in commit to parent. And Matthew is telling us that he upgraded yesterday, and since this is the only comment, I am going to assume that he had no problems and is running fine. This is all we have on the execution layer client today. On the consensus layer client, we have a new Prism release. So this is version 4.0.2. So first of all, what you need to know about this release is that it fixes a critical bug on Prism interacting with MEV boost relayer. This means that you must upgrade to this release if you run Prism included with MEV boost and relayer, or you'll be missing block proposals during the first days after the 𝗨𝗪𝗂𝗧 fork. And some of the things that were included in this release. So on the CLI side, there are added new beacon node flag, local block value boost, that allows local block value to be multiplied by boost value. There have been various Beacon API client endpoints. So get sync status, get genesis, and list validator endpoints were all added. There were a lot of fixes, particularly in the Prism API. It fixes deadlock in stream chain head, and in terms of block processing, add orphaned operations to the appropriate pool, and for block construction, default to local payload on error and on nil value correctly. Again, a lot of changes, but you need to upgrade to this release if you run Prism with Relayer and MEV Boost. And Matthew is also saying, I changed from internal consensus layer to Lighthouse on Aragon. So does that mean you changed from Prism to Lighthouse? I think that's what it means, yeah. Oh, I see. Okay, from internal CL. All right, we also have a new release for Lighthouse. This is release number 4.0.2. This is a pre-release. And this is a high priority hotfix that addresses the high CPU usage experienced after the Capella upgrade. And all mainnet users should update to this release to prevent high CPU usage from interfering with normal node operation. This hotfix only applies to the Beacon nodes, and there is no upgrade to the validator client from a version 4.0.1 to this release. Also, just a question to everyone here. Internal CL is actually not included at the moment in the repo watch. Is that something that we want to include in the future? And also Anton is confirming that syncing the new version of Prism and is going well. And I will include internal CL in repo watch for next week. I'll figure this out. Okay, on the graph stack, we have a major new release for indexer agent and service. So this release is version 0.20.15. The following packages are part of this release. So indexer agent, indexer service, indexer CLI, indexer common and native, and they're all on version 0.20.13. Some things we need to know about this release. Thanks to the epoch subgraph, indexers can now connect to any protocol network and claim rewards for indexing subgraphs on the new supported networks, the Gnosis, Avalanche, 𝗨𝘀, and Arbitrum-1. Testnet is also live on 𝗨𝘀, where the following networks are available, so 𝗨𝘀, Phantom, Polygon, and Optimism. And we're finally all on L2 with Arbitrum-1 and Arbitrum-𝗨𝘀 testnet, both being live protocol chains. This release has a lot of action queue updates. So action queue was fully added with the new subcommon, which is a new subcomponent responsible for managing a set of actions. So allocate, unallocate, and reallocate for an indexer in a predictable and efficient way. And these actions can be generated both by indexer rules and by direct input, and are sent to a dedicated worker process to be executed. Here you can use the new parameter startup parameter, allocation management, which has been introduced to let all indexers choose between different allocation management modes, so auto, manual, and oversight. There's a lot to talk about here, so I won't go through each one of these allocation management modes. We have had in the past various presentations of the action queue and these allocation management modes. So please do check the release notes where you can read more about it. And these new action query commands are all available to inspect and manage the action queue using the indexer CLI. Please let me know if anyone has tried this release. And while I hear from people about this release, I just want to just quickly go back to the question about internal CL. So a few of you are saying that it's no longer recommended. So I will not include it in repo watch. Thank you for commenting on that. And Vincent from Data Nexus is saying, after every hard fork, you can't restart the internal CL for 12-15 minutes due to light client limitation. Okay, that is it for repo watch. Handing over to Juan, unless there are any other comments or questions.
I'm gonna give it 1 minute just in case.
I can see Matthew typing. I'm wondering, Ford, if you have any comments about the new release of Indexer Service and Agent. If there's anything that I haven't mentioned that you want to add. Nope. Okay, cool. Then over to you, Juan. Thank you, everyone.
Thanks, Hannah. Okay, heading into Protocol Watch, we have a few things to discuss. First of all, forum governance 𝗨𝗂𝗂𝗂𝗧, exponential query fee rebates for indexers. As I understand, it was discussed last week, but there was a clarification on the removal of channel dispute epochs that Thomas added to the thread, basically making sure that it's known that it was not really needed as a part of the protocol, given that it's not used after we moved from state channels. It was only required for state channels to work properly, and it's no longer needed, so that's why it could be removed. Next up, we got 𝗨𝗂𝗂𝗧𝗨𝗂, a world of data services. There's a new comment from Derek explaining some potential use cases for SQL aggregations on patterns that aren't particularly performant in subgraphs, like, for example, things that would require you to update a lot of entities every time there's a single change in one of the fields of any of those entities. Those things could be aggregated through SQL rather than having to actually go through all of those batch updates in a subgraph. So yeah, that's another use case that's quite interesting. Next up, we have a new update in 𝗨𝗂𝗂𝗧. This is the L2 migration helpers. There were a few changes to the current helpers. There's a summary that Pablo mentioned, which I also posted in the agenda. That summary includes proposed modifying the arbitration charter to make L1 offenses slashable in L2 if the indexer tries to evade slashing by migrating the stake to L2. This was also noted during the audit. I think it's the OpenZeppelin audit. Also, subgraph IDs will have to be aliased in L2 to avoid conflicts. The 𝗨𝗂 also now specifies the aliasing formula. It's basically like a mask. And there are more details in the changes themselves regarding the vesting contract migration for both fully vested and still vesting contracts. Forum research has no new updates since last IOH. And then we're moving to contracts repository. There's a bunch of open PRs, mostly regarding OpenZeppelin audits, both audit notes, as well as some fixes to those points made in the audit, mostly regarding the L1 GNS, L1 staking, so mostly the migration helpers and all of the necessary changes in the contracts to allow for the migration helpers to work. Also a few chores and stuff, but those are not really important. Next up, we have the network subgraphs. There was a small issue the past week regarding Arbitrum. There was an issue with the GNS contract particularly, which caused the subgraph to fail. This was due to ENS not being present in Arbitrum. This was fixed both for the core network subgraph and the analytic subgraph in version 0.19 on both of them. I tried to sync the versions so that they make sense. But that's pretty much it for all of the changes for Protocol Watch. So I'm going to hand it over to Abel now.
Wonderful. Thank you so much, Anna and Juan, for your respective sections. So we are very fortunate to have David Lutter with us today, who's going to give us a presentation. And I won't spoil it. Instead, I would say that there are some tips that are going to be shared that will help, hopefully, many of you level up your indexing game. So I will share my screen, and then I will hand it over to David to take us into today's workshop. So can everyone see my screen? The thumbs up or something, or some sort of recognition. Yeah, perfect. Thank you so much. And then David, by all means, take it away.
Okay, yeah, I'll start. Yeah, so this presentation came out of an internal presentation I gave a few weeks ago for a bunch of people like solutions engineers, SREs, and so on, that help troubleshoot the hosted service. And I think there's a lot of good stuff for indexers in there too, at least as like background knowledge and some tips on how you can investigate some problems you might encounter. Next slide, please. So I thought to start off, I'll just talk a little bit about what, I talked a few weeks ago about sharding, what a really, really big graph node installation looks like in terms of shards. I don't recommend that anybody runs out and changes their setup this way, but some of the thoughts that went into that might be helpful when the day comes that that you need more than just one shard. So in a very large setup that I'm not going to name further, we have several shards. One is the primary shard, and I'll talk a little bit about what makes the primary in a minute. We have shards for just the block cache because accessing the block cache has some characteristics that don't mix all that well with accessing subgraph data. Particularly the block cache can get very bandwidth limited because we're moving a lot of data around, especially when you're indexing chains with very large blocks like Polygon and BSC. Then we have a bunch of shards that just have subgraph data. And then finally, we have a shard for really high volume subgraphs. And to that, we have read replicas hooked up to spread the read load. But as I said, this is not something I recommend anybody doing right away. You should start with a single database, which once you scale out, will become your primary. That's why it says also some really old subgraphs. That's how we started, and we still have some subgraphs in the primary, which is totally fine. But in general, the primary, if you had just the primary as a primary, no subgraph data, no block caches, it would be a pretty small database. Next slide, please. So what makes the primary is a few tables in there that are sort of the authoritative source for information. Two of them are just directories. One is the table chains, which just says where the actual data for any given chain lives. Right? It has an entry like mainnet is in this shard, which might be the primary, again in a single database setup or some other database. Same for deployment schemas. That's a list of all the deployments that GraphNode knows about, and what network they're on, what shard they live in. Some high level, very static information, and more detailed information than lives in the individual shard. And then the next two tables, subgraphs.subgraph and subgraphs.subgraph version, are just concerned with translating subgraph names to IPFS hashes and the deployments. And then finally, there's the subgraph deployment assignment table, which has an entry for every deployment and says, this deployment is indexed by this index node. If you're curious about more of what the metadata for GraphNode looks like, there's this link to documentation that has a list of all the metadata tables and what the attributes of each of them mean. Okay, next slide. So this came out of, this section came out of some trouble we had with RPC providers in the hosted service. Next slide. If you haven't used any of the GraphMan chain commands yet, the simplest is GraphMan chain list, which just lists all the chains that GraphNode knows about, what shard they're in, what namespace is used to store the data for them. And version is the net version from the RPC provider. Head block, I think, is self-explanatory. Next slide, please. So for newer setups, each chain, the block cache for each chain goes in its own database schema, its own database namespace. Postgres has a little bit of unfortunate lingo there. It calls namespaces schemas, but they're really just namespaces. And so in each of those namespaces, you'll find 3 tables. The blocks table, which has the actual block data for blocks that we've seen. It's a fairly simple table, like block hash, parent hash, block number, and then a big JSON glob of the actual block. Then there's the call cache, where we cache calls for ETH calls that subgraphs make. So every time a subgraph makes an ETH call, we first go to the RPC provider, get the result for that call, and stuff that into the database. So if a similar subgraph makes the same call, we don't need to go back out to the RPC provider. We can just get that from our cache in the database. And call meta isn't very important. It's some metadata around the call cache, around when entries were last used and all that. Okay, next slide, please. So one of the problems we encounter quite a bit in the hosted service is that some RPC provider feeds us back bad data. Sometimes we get a block that's not right, or we get a subgraph makes an Ethereum call and the result that comes back is not right. But because the data is cached, if you run into that situation, you need to sort of manually fix it with one of these 2 commands. The checkblocks command just goes back out to the RPC provider and re-downloads the block, basically. I think it also verifies or notices whether there were differences between the block that's cached and the block it got from the RPC provider. And the call cache remove command lets you just remove all the Ethereum calls that were made for a range of blocks, in case the RPC provider responded with bad data for calls. Like, I mean, the cache won't cache things like errors. When we make an Ethereum call and we get errors, but sometimes we make a successful call and the data is still not right. And in those cases, you might have to use this call cache remove command and then rewind subgraphs that are affected. I should have listed GraphMan rewind here too as a tool to get out of a situation like that. Okay, next slide. This came out of a question about how do I even know how big a subgraph is? Next slide, please. There's in the database, there's materialized views in the info namespace. They're called info.subgraph sizes, info.chain sizes, and then there's also an info.table sizes. In the releases that are out right now, those materialized views need to be refreshed manually. In the next release, GraphNode will refresh them automatically every 6 hours. And the things to look at, the screenshot here is just from a dashboard we have where we basically do a select star from info.subgraph sizes and make that look a little pretty in Grafana. But what these columns mean is, total bytes is like how much storage that subgraph takes up on disk altogether. Table bytes is basically just the data in the base table. Index bytes is how much space the indexes built on top of the data take up. And then toast bytes is how much Postgres has like special large object storage called toast. Best thing since sliced bread, apparently. Where if you write an entity, if you write a row that has very large, that is too large to fit into the normal table, it'll extract data and put it into toast storage. And this is sort of, usually toast is one of the drivers of why subgraphs become really humongous. Like you can see the first subgraph on this list here is 6 terabytes, which is not great. And almost all of that is in toast. And almost always, like I don't think I've ever seen an example where that was not true. The reason why you have a lot of toast is because the subgraph uses very large arrays, like arrays with 100,000 entries in their entities. And that's sort of an anti-pattern, and I really want subgraph authors to stop doing that. Like if a subgraph has arrays that are stored directly, like arrays that are not derived arrays. Derived arrays are fine, but if the array is stored directly, people should try to keep the size of those arrays to a few entries, like 10, 50, 100 maybe, not 100,000. And what also happens with subgraphs like that, just indexing speed gets very, very slow because there's a lot of data that gets moved around every time one of those entities gets changed. Yeah, and there's a similar view. I don't have a screenshot for that. The info.chain sizes that can help you see how big the block cache for each chain is. Okay, I don't know if I can follow the chat while I'm talking. Yeah, that's a good question that I don't know the answer to. How would a user know who to complain to on the decentralized network? And it's true. I have to double check the code, but if you use the firehose, we don't cache the blocks. I think we only cache, hash, parent hash, block number, which is very little data. And so the solution out of very large block caches is firehose. But as to who to complain to on the decentralized network, I guess you would have to somehow find out who published that subgraph. But I think there's definitely a coordination point that should be made easier. Okay, next slide, please. Yeah, so another area that pops up quite a bit is that people complain that they're running some query and it takes a really long time, or you see the load on a database shoot up to 100%, 95%, whatever. And so I'm going to talk a little bit about some tools around figuring out what queries cause high database load and to investigate a little more long-running queries. Next slide, please. So we have a dashboard that shows the pgstat activity table from Postgres. And pgstat activity is sort of like top for an operating system. It lists all the queries that are going on right now, how long they've been going on, what the query is. You can also get out of it like which connection the query came from and all that. So we have a Grafana dashboard that shows pgstat activity. And the columns we show there is like the client gives us an indication of where the query is coming from. Q- means it's coming from a query node. The PID column is basically the process ID of the Postgres connection. Like in Postgres, each connection is its own process. And so if you have a query that's really, really long running, you can go into Postgres and use pg cancel backend or pg terminate backend to kill that query. You might want to be careful about what you're killing there, but if you see a normal query that's taking 10 minutes, you might want to kill that. For queries that we run as part of a GraphQL query, there's a timeout, like the SQL query isn't allowed to take more than like 100 seconds. By default, it's an environment variable you can set to set that timeout. There's both a timeout for each individual SQL query and a timeout for the GraphQL query overall. And so if you're struggling with really long running queries, like several minutes, you might want to look into setting those environment variables. And then for queries that come from GraphQL queries, they get annotated with a bunch of comments that tell us, what's that, the fifth column shows, some information that's parsed out of these comments, like what subgraph is it, the internal identifier, that SGD, the query ID, and then at what block the query is being run. The query ID consists of two parts. The first part before the dash is the shape hash. So all GraphQL queries that have the same shape, basically that are the same if you don't look at different arguments. Like, so the same query that says first 100 and first 1000 will have the same shape hash. And the second part is basically a hash of the query itself and the variables. And that query ID is important if you want to look at your query logs. If we can go to the next slide, please. So what this shows is we use Loki internally to look at our logs. And so you can run a query in Loki that looks for a certain query ID. And at the bottom, that box shows what comes back. Like in reality, this is one line, but I broke it up a little bit to make it more readable. So those lines all start with query time in GraphQL. It's something you need to enable with an environment variable. It's called, I think, GraphQL log query timing, something like that you need to set. And then for each query that gets run, GraphNode will log this information about the GraphQL query. And so that log output tells you at what block the query was run, how long it took, what the variables were, what the GraphQL query was, and the query ID. So if in your pgstat activity you see a query that takes a really long time, you can take that query ID and find the GraphQL query that causes that using the logs. Okay, next slide. So and I think this is released, it might not be, I'm not entirely sure, but it's definitely going to be in the next release. I hope you all know about the news.md file in the GraphNode repo that has like our release notes, and we try to keep some notes about what's going into upcoming releases in there too, so it's worth checking that file every once in a while. So you can set as an environment variable, you can set this trace token environment variable to some secret, and then when you make a GraphQL query and include the header xgraph trace query, and you have the right token there, then the response to the query will also contain a trace of the SQL queries that were run. It'll show you for each of the SQL queries that get run, shows you the query, how long the query took, how many entities came back. And if you need to investigate why a certain GraphQL query is slow, you can get a trace, find this. Usually it's one SQL query that's slow, find that SQL query, and go nuts with getting query plans, trying to create indexes to improve the query plan and all that. But I find this very useful to investigate sort of what makes a GraphQL query slow. You can also get a trace with Graphman. There's a Graphman query command that you can also give a GraphQL query, and that will run it and also produce a trace. But of course, doing this as part of the GraphQL query is much more convenient. Okay, is there questions in chat? Maybe we'll do those later. Okay, next slide, please. Just want to talk a little bit about the database statistics and Graphman tooling to create indexes. Next slide, please. The graphman stats command can show you a bunch of statistics about an individual deployment. The graphman stats show will just list all the tables that belong to this deployment, and then how many different entities are in there and how many versions are there. Versions basically means rows in the table, and entity means rows with distinct IDs. The information that gets shown is, we don't do a count when you run that command. That would take way too long. The information is used on the statistics that Postgres keeps for its query planner anyway. So it's approximate, but it's usually pretty good. Then the next command you can use to analyze a table, which will tell Postgres to go through that table and gather statistics again. It tries to estimate how many rows are in the table for each column, how many distinct values the column has, and some other stuff. That's information that Postgres uses internally for query planning. We use it for this show command. And it's probably the first step in, if you see that a query against a certain table is slow, analyzing the table can sometimes be really, really useful. Can happen that the statistics are so out of date that Postgres just generates bad query plans, and running analyze will fix that. Postgres has mechanisms internally that reanalyze tables periodically, but it can still happen that it can occasionally happen that running an analyze actually fixes a query performance problem. This account-like thing is that's unfortunately a little bit black magic. If you set the account-like flag on a table, that changes how queries get generated, and it takes about 5 minutes between running this command and the query nodes actually picking up that this flag has changed. And depending on the table, turning on this account-like optimization can be really, really beneficial for performance. Unfortunately, for some tables, it can also make performance much worse. So generally, when you set this account-like flag, you need to watch the queries for 10, 15 minutes to make sure it didn't do anything bad. The account-like flag is really, really useful for tables that keep lifetime statistics of something. So for Uniswap-like subgraphs, that's like the token tables called token, pair, pool. Those things are really, really helped by having this account-like optimization on. I would love if we had an automated way to detect when that would be helpful, and we wouldn't have to require people to actually run this command. But for now, that's all there is. But if you see slow queries for like a token or pair table, it's definitely worth just running this command and seeing if that improves the query performance. The last two commands on this slide have to do with how Postgres gathers statistics. When Postgres analyzes a large table, it doesn't go through the entire table and to see how many rows there are and all that, because it would take too long. So it just takes a sample, like it samples some pages from the table. The first command just shows you if there's any special things set for this, how much to sample. And the second command, the set target command, lets you change how much of a table Postgres will sample when it analyzes. And again, this can have, for large tables, setting the target to 200, 500 can be really beneficial, because then Postgres has better statistics about the data in the table and can generate better query plans. So again, if you have large tables and slow queries against them, setting the statistics target for them can be really useful. Next slide. Graphman also has some commands for managing indexes. The simplest one is you can, for a subgraph or a table, you can list what indexes there are. By default, GraphNode creates a lot of indexes on tables, so the -D suppresses those default indexes because they're usually not super interesting. And with a -D, it just shows you indexes you've created manually. You can use Graphman to create an index. That's better than doing it in P-SQL for two reasons. One, you should always create indexes concurrently because the non-concurrent index creation locks the table and blocks queries while the index is being created. And the concurrent index creation that this command does, it doesn't have that problem. The other one is that we have a naming convention that indexes that are created manually start with manual underscore, and so Graphic index create takes care of queuing to that naming convention. There's nothing that really relies on that, but it's useful to have this naming convention when you later need to go in and see how many indexes have I created, or what was that index I created for this other subgraph. Maybe that helps for this subgraph too. And then the last one is just a way to drop an index. If you maybe you created an index, it didn't help, and you want to get rid of it again, you can use that. But there, drop index in P-SQL is just as good. Okay, next slide. This is more for people with more than one shard. There's ways to move subgraphs between shards. Next slide. The way you do that is by copying a subgraph. Behind the scenes, grafting and copying are almost the same thing. In both cases, we determine for the source subgraph how much of the data to copy. We copy that into a new deployment. And then the difference between copying and grafting is that after we've done the copying, for copy, we just run that deployment with the existing code, and for grafting, we switch to new subgraph code to do that. It can take a while if your subgraph is large. I've seen copies take days or weeks, but I mean, for small subgraphs, it'll usually take a few minutes, maybe a few hours. The really long time is definitely an exception. While you're copying, the copy operation is broken into relatively small batches to make sure, for one, if the index node is restarted in the middle of copying, that you're not losing too much work. Also, to make sure that we don't have really long running transactions because they do bad things to the database. In the primary, there's a table called active copies that lists all copy operations that are ongoing. If you want to keep an eye on how much grafting or copying is happening in your graph node, you might want to have a dashboard for that. We use that to move subgraphs, right? Like subgraph got deployed in a shard that can't really handle high traffic volume. So we use that sometimes to move a subgraph into a shard that can handle a higher traffic volume. And the way you copy is there's this graph copy create command that does the copying. You can use graph copy a list that basically just shows you what's in this active copies table. And then for each individual copy, you can do graph copy status, and that just shows you how far the copy has gone, which entities have been copied already, which ones are still in progress, and details like that. If you run graph copy create without this replace flag, it'll just make the copy, and then you have two deployments, two basically identical deployments syncing at the same time. If you pass -- replace, it will do the copy, wait for the destination to catch up to the chain head, and when that happens, it'll shut down the source of the copy and unassign it, and so you'll have the data sit around for a little bit, but the unused deployment Reaper in Graph Node will eventually get to it and delete it. I also think that the -- replace, like graph copy create, has been around for a very long time, but the -- replace, I think, is not in release yet and will be in the next release. Okay, next. Indexing metrics. There's some metrics that we collect that can help shed some light on what a subgraph is doing while it's indexing. I don't know how many people have played with it. Next slide. The metric is called deployment sync sex, and it's keyed by deployment. What we do is we have a dashboard that shows, that this is PROMQL. That sum at the top, that's the total time that indexing has taken so far. Indexing is broken down into a pipeline that consists of 3 stages. The first stage is extracting triggers from the chain. The second stage is processing those triggers, and the third stage is writing those entity changes to the database. And those 3 stages run in parallel. So we don't have the sort of first stage, the trigger extraction, as instrumented as its own stage. So when you do sum by stage, you actually get 2 values, one for processing, for trigger processing, and one for writing. And then there's various sections in that. That's the third PROMQL query, where you sum by section and stage. It's always that sum of increase, blah, blah. Horizon is, how far back do you want to look in the indexing that's been going on, right? Like sometimes you only want to see what happened in the last hour. Sometimes you want to see, how indexing has been performing over the entire time the subgraph has been indexing, in which case you would set horizon to something really large, like a year or something like that. Next slide, please. And so a screenshot of what that looks like in our Grafana dashboard is this. So the total time is actually, that's sort of a goof up in the dashboard, is actually twice the time. It's just the sum of the 2 stages here. And you can the 2 stages should also always take the same time, but there was a bug in GraphNode where the writer stage kept running after, or kept measuring things. That bug is fixed. Not sure if that's in the release. So those 2 stages should always show you the same amount of time. And then there's entries for each section. And if you go to the next slide, please, there's I have some explanations for what those sections mean. So as I said, total is 2 times the time spent indexing, and process and writer stage will always be the same. The way you can tell whether processing triggers is falling behind or writing to the database is falling behind are those next 2 sections. If you see a lot of time in transact block, that means that the trigger processing stage is waiting for the database writer. Basically, when processing is done, it just hands a whole bunch of data to the writer, and the handover is in this transact block section. And if the writer is busy and the write queue is full, the trigger processor has to wait for the writer to have room to take the next request. Conversely, if you see a lot of time in queue wait writer, that means the database, the trigger processing is the bottleneck. And some of the reasons why trigger processing might be the bottleneck is if you see a lot of time in host export store get, that comes from loading entity when mappings read data from the database with store.get. That's what that section means. So that's the time that the mapping spent reading stuff from the database. The host export Ethereum call is how much time was spent making ETH calls. That can also take up considerable amount of time for some subgraphs. If you don't have a call cache populated on the hosted service, at least, because all our RPC providers are pretty far away from us, that can absolutely dominate and trash indexing performance. So those are 2 things to look out for. And the last section is if you see a lot of time there, you probably have a lot of contention for database connections, like the connection pool for your index node is not big enough, or your database is not fast enough to keep up with the write load. Okay, next slide, please. This is maybe not so much something that indexers can do, but if you ever talk to anybody who writes subgraphs, it's something I've been trying to evangelize for. As I mentioned earlier, like large arrays are really, really bad for performance, for storage, and all that. So subgraph authors should avoid large arrays as much as possible. If you have arrays, directly stored arrays in your subgraph, keep them small, maybe 10 to 100 items or so. We're adding some host functions that will hopefully reduce the need for large arrays. One is this load-related host function with which you can access derived fields from mappings. Right now, that's not possible. If you're working on an entity that has a derived field, you can't really load the entities for that derived field. So the load-related host function will make that possible. And the other one is a performance improvement. Like if you know in your mappings that something you're trying to look up has to have been created in the same block, you can use this load-in block. It sometimes happens that one handler wants to check if a certain transaction has happened in the block beforehand, and it knows that there's no point in going to the database. So using this load-in block can reduce database round trips and overall improve performance. The other two things are two things that I've talked about for a while. Subgraphs should use bytes as the type for the ID field as much as possible. If you're dealing with entities that are addresses or something like that, don't store them as a string, store them as bytes, because storing a string takes twice as much space as storing them as bytes. And also, if entities are immutable, so if your subgraph just pulls data off the chain and stores it in the database, you should mark those entities as immutable in your GraphQL schema. That allows us to not build some very expensive indexes. We can build much cheaper B-tree indexes for certain things. And if you want to know more about this, I wrote a blog post about all this a while ago, and there's also some performance numbers. Like in the subgraph we tried it out with that 𝗨𝗀𝗧𝗧 wrote for us, thanks to 𝗨𝗀𝗧𝗧. Using those two things together showed a 30% improvement in indexing time and in storage size. So it's quite considerable. Okay, this was pretty much it. I have a couple more slides. Abel, if you can go to the next, or one more slide. If you really, really want to get into databases, the CMU Carnegie Mellon has the database group there has an absolutely fantastic YouTube channel. Two specific videos I recommend watching. The first one is on the history of databases. There's a famous paper, "What Goes Around Comes Around" by Stonebraker and Hellerstein, where at least the intro everybody should read, because it's pretty funny, because Stonebraker sort of losing his shit with all these young whippersnappers who come up with these great new database systems, and he's like, we tried this stuff in the 80s, and here's why it doesn't work. But it's not just sour grapes. It's a really informative overview of database history from sort of the 60s, 70s. There's Andy Pavlo at CMU gave a lecture where he basically goes over the paper. The other one is, if anybody wants to know more about what this relational algebra is and sort of the theoretical underpinning of SQL, that's also a lecture by Andy Pavlo that I highly recommend. And then if you really want to get into it, they have two of their database classes online. The intro to databases is really, really good because it goes through all the different pieces that make up a relational database, starting with the buffer cache all the way up to the write-ahead log and all that. It's long. It's a whole semester course, but I think it's fantastic and can help with a lot of sort of the lingo and thoughts around how databases work. And then the advanced database systems class, I think this semester it's mostly on OLAP, but that's a little more specialized. Okay, next slide, please. Okay, there's some more materials, and I'll make those. I'll give I'll make all my slides world readable, so you can get to all these links. after this, and I'm sure we can put them in the YouTube description or in the indexer channel. This use the index loop is a really good resource on how indexes work and when to use them, and when they may or may not be beneficial. In general, the Postgres docs are, if you haven't looked at them, they're fantastic. They're like some of the best docs I've ever seen for any piece of software. It's always worth checking them. There's also, I think that's a Japanese website about Postgres internals that's much more oriented towards how Postgres is implemented internally. And then there's a guy, Bruce Momjin, whose website, he gives presentations at pretty much any Postgres event. And he's got a lot of really good presentations on a wide range of topics around Postgres. Okay, that was it.
All right, thank you so much, David. Lotte. So that was a great in-depth presentation. I'm going to link it there so people have access to it. It's not public, right? Not yet.
I'll make it public. Give me.
Yeah, no worries. Fantastic. Well, we're at the top of the hour, but I know that there are a few questions in the chat. So maybe, Lotte, if you could have a look at the questions here. I know that 𝗨𝘀𝗲𝗂 is doing a fantastic job of answering some of these ones here, but if there are any ones that are still outstanding, maybe you could answer them. And if anyone has any. Mm-hmm.
If anybody, so I just made the slides public. You should be able to get to them. Have you tried any of the Postgres extensions cited, like Citus, 𝗨𝘀𝗲𝗂 for indexers? No, we haven't tried it. We used 𝗨𝘀𝗲𝗂, or we tried to use 𝗨𝘀𝗲𝗂 for the gateway, I think, and our experience wasn't all that great. But I don't know the details. I didn't do that. I mean, definitely something that's interesting to look at. I've been meaning to look at Citus because especially their sort of analytics-oriented the parts of their extension, but I haven't really done that yet. Okay, when implementing sharding, if we're using replication and/or log shipping, would our replica also need to have the same sharded structure? So what we do is we just use physical replication, not logical replication. And so we have one shard that's replicated. So we have one shard that's sort of for high traffic things, and that has read replicas hooked up to it. And in the GraphNode config file, when you tell GraphNode about those replicas, you can also say how much traffic to send to each of those replicas. So replication is per shard. It's not for the whole thing. Hope that answers it. Okay. I don't know if somebody has an overview of. I'm scrolling back, but if somebody wants to.
Steak Machine just tagged, reposted his question. So let's see. So should we do graph and copy only? Should we do graph and copy only on unallocated subgraph?
That's a good question. I'm actually not sure about that. I don't know if 𝗨𝘀𝗲𝗂 knows. So from the GraphNode side, copying is transparent. Like the outside world won't know that you've made a copy. But I don't know if there's any problems where the indexer agent and GraphNode could get into a fight if you copy things. But when you make a copy, it to the outside world, it still only looks like you have this deployment once. Serving data won't be compromised during copy. So especially if you use the --replace flag, like when you just make a copy, queries will still go to the original, and then you can manually check when your copy is done and has caught up to the chain head. There's a separate command, grafman copy activate, that will then switch queries over from the source to the destination of the copy. And so as long as you do that switch over only after your copy has caught up, you won't have any compromised data. And there's this -- replace flag which will sort of watch and do that automatically. And then there's also a second flag that will keep the original but still send copies to the destination, and I forget what that flag is called. But that the help for create will have it. Okay, are there more questions that I haven't answered yet?
Not to my knowledge, no. But if anyone else has any additional questions, please feel free to shout. Either type them in the chat or on the mic. I see Vincent and Marc-Andre.
Typing. It's going to be a long question. How large of a performance impact is there to the DB when copying? In my experience, not that much. I mean, the biggest concern is probably in sort of the destination shard, because it does create write traffic, right? Like if you have the I/O bandwidth, sort of headroom in your I/O bandwidth. But generally, it's pretty unproblematic. The copy logic also throttles the number of things that can be copied at the same time to avoid that a bit. But as I said, like in the hosted service, I don't think we've seen much trouble from copying. What's the best way to ask more questions? Maybe a DB channel. That is a good question. I don't know what the best channel is. Maybe just the indexer channel, or
I would say let's try and put all the questions in the indexer channel. If there are any kind of specific requests to make a specific DB channel, then we can explore that. But I'd say let's default to indexes, if that's okay.
okay. Are there more questions?
Looks like a few other people are typing. What do you mean, Marc-Andre? I'm not sure if I can pass what you said there.
Oh, do you mean that questions aren't forwarded enough to the right people?
Can you hear me?
Thanks.
Yes, we can. Yep.
Okay. Yeah, sorry, I wasn't sure about my current microphone setup. I was just I was wondering if maybe a specific channel where we could have all the DB geeks hanging around, like subgraph developers interested in optimizing for graphs, indexers that want to come up with more complex setup, and maybe even you, Lutter, that's a channel you would like to hang around, and basically all the people who care about these things, they could exchange ideas and tips and share their experience.
Yeah. I mean, we also have this engineering channel. Yeah, I'm a little out of my depth what the right place for that would be.
Yeah, I see that Pedro's typing, so maybe Pedro has some comments.
Maybe, Pedro can try and coordinate something someplace.
Yeah, I think it could be reasonable to have a channel like that. I think it could be fun. Oh, can't talk. Okay, no worries. Yeah, I think it could be interesting. We'll think about that, and if if it makes sense, then we can facilitate. I'll let Pedro maybe comment to that very quickly. Sweet. Looks like Pedro said it's a good idea. So, yeah, I think we can move forward. Cool. Well, I'll coordinate with Pedro to get that sorted. I see Vincent typing. Anyone else? Final questions? We are a little bit over. So if you have any final questions, just feel free to pop them there and we can answer them. If not, then we can wrap for today's conversation. I'll just give you guys a couple of seconds. Yeah, that's a good shout, Pedro. Cool. Well, I think we can wrap today's conversation. Thank you so much, Lotte, for the workshop. No worries.
Thanks for having me. Thanks for everybody who attended.
Yeah. It's always a pleasure to have you at IOH. I think we all learn a lot when you do a workshop. So I've linked the presentation there so you guys can check it out. We will hopefully do another one of these at some point in the future again, because obviously I think these are helpful. I think people are engaged and ask a lot of questions. Thank you all for attending, and I guess I will see you all next week. Take care, everyone, and bye-bye.
Okay, bye.